Okay, so this video I'm doing by request. I've already made a series of videos about trig substitution, but it doesn't hurt to have more problems to look at, all right? And, they're all a little bit different, so, I haven't done this exact problem, so I think it's a good thing to do. So this is a trig substitution problem. We'll start there, okay? We learned lots of techniques for doing these kinds of problems, but this is trig substitution. The substitution that I want to make is x is equal to 6 sine theta. And you can decide on this substitution based on the guidelines that I've given in other videos. But what will happen is when I put that here, I'll get the 6 and I'll square it and it will be 36. And then I'll factor out the 36 and I'll get 1 minus sine squared and I'll simplify it from there. Even though every problem is different, the same kind of thing seems to happen on every problem once you make the substitution. So that will be my x, and as a consequence of that, I'll substitute for dx 6 cosine theta d theta. All right, so that will do it. Now let's put that over here and see how it works out. So the 10 is not involved in the substitution. The 10's a constant. And then I get root 36 minus, now imagine if I took this x, 6 sine theta, and I squared it. 6 sine theta all squared. That's 6 squared and sine squared. So that's going to be 36 sine squared theta. Okay, so that's what I was saying would happen. And that's why you want the 6 to be there, all right? It won't work without the 6 because then you won't have that common factor of 36. The dx, that'll be 6 cosine theta d theta. All right, now let's see what we can do with this. How about I'll focus on that part under the root right there. So just look at this part under the root, okay? Forget about the rest of it. I'll factor out the 36. I'll get 1 minus sine squared theta. And then there's an identity for that. So what I really have under the root is 36 cosine squared theta. So imagine this is the square root of 36 cosine squared theta. The thing about roots is that if I have the root of a times b, then that is individually the root of a times the root of b. So we're taking advantage of that right here. It's 36 times cosine squared. Square roots will apply individually to factors. You might say, why didn't you do that from the beginning then? Well, roots do not distribute across addition or subtraction. The root of number a plus or minus number b is definitely not the root of number a plus or minus the root of number b. So the substitution turns subtraction by trig identity into multiplication. That's how it works. All right, so we are taking advantage of this right here. All right, so here's what we're going to get then. I'm going to have, let's do this. Let's say I got this 10, okay? And let me move this 6 cosine theta away from the differential. It's part of the integrand. So I'm going to say 6 cosine theta. And then this differential d theta I'll leave over there. And then what is the square root of 36 cosine squared theta? Well, what's the square root of 36? That would be 6. What's the square root of cosine squared? That would be cosine. So I get like this, okay? And this reduces. I didn't have a way to reduce this. That one is irreducible. I really don't have a way to reduce it that's going to help me work it. By substitution, I get something that reduces a lot. Look at, here's all that's left. The 6's cancel. The cosines cancel. All that I have left is 10 d theta. Do you know the antiderivative of 10 d theta? The antiderivative of 10 with respect to theta. Theta is the variable. That would be 10 theta plus c. Okay. So we got to the point where we could find the antiderivative. Now, what we will typically do is once we find our antiderivative, we will put it back in terms of the variable we started with, that's x. How do we put theta in terms of x? Here's the link between them. Okay? So how did we work this problem? What was the assumption? The assumption was that x would be 6 sine theta. That's the connection between theta and x. How do we get the theta back in terms of x? Do we draw a triangle? No, that's not going to help us this time. Why not? Well, because that doesn't say cosine theta or secant theta. It's not something that we look at a triangle and say, well, you want the opposite over the adjacent or something like that. This is just theta. Okay? So how about this? If you could solve this equation for theta, that would be the substitution back for x. All right? So here's what we want. Let's say sine theta is x over 6. Could you agree with that? And then that would make theta equal to inverse sine of x over 6. There we go. That's what we want. That's what theta is in terms of x. So our answer will be 10 times inverse sine x over 6 plus c. Okay? All right. Now about this inverse sine, it's just the difference between the angle and the number. I mean, you could say sine of 45 degrees was 1 over root 2. That's a true statement. You could also say, if you wanted to, that 45 degrees is sine inverse of 1 over root 2, right? It just depends on what you want. They're both true. If you want to say the angle is equal to something, you do it this way. If you want to say the sine of the angle is equal to something, you can do it that way. This is what we do this all the time in math. I could say 6 squared is 36. Or I could say 6 is the square root of 36. They express the same truth. It just depends on how you want to arrange it. All right. So for this one, drawing the triangle is not the approach. To put our answer back in terms of x, we just use the inverse function. That's all we need to do.